Naji here. In this video, we will be discussing on parent document retriever. This is very interesting retriever, and we'll see in which scenario we will use the parent document retriever. So when splitting a document, there is actually a few or like a conflict in this case are there. One is if the document is small or if you splitting the document into small chunks, the embedding accuracy will be very high, but it will actually lose the meaning. Okay, so we need to have a to get the context, we need to have a long enough document, right? Then only we will get the exact context of that particular situation. So parent document retriever actually help us to do this. So we will have two kind of splitting is happening in parent document retriever. One is it will split the document into small chunks, okay, and whenever we run a query, okay, then it will actually compare with these small chunks. And what the parent document retriever is, it will always keep a record, always keep a ID to the parent document, that's the entire document, so that the initial search will be done with these small chunks. Okay, but whenever we do a context or whenever it return a context, it will return the entire document or the big context will be returned. So that is how the parent document retriever will work. So this is very simple. So whenever consider it as a two splitting happening between in the parent document retriever. So whenever a comparison is happening, always the small chunks will be compared. Okay, then when the match is occurred, when it returns, so when the document document dot invoke is happening, it will actually return the big chunk, not the small one. So we'll see how this works. So let me go to the Visual Studio Code. Okay, so we can import the parent document retriever from the Langchain. So let me select the kernel first here, and we can have a Langchain dot retrievers. We can not request, it should be retrievers. Sorry, retrievers. We can import parent document retriever. I can explain it with the code, that will be very easy. From Langchain dot storage, we can import InMemoryStore. From Langchain dot underscore Chroma, we can have a import Chroma. From Langchain dot community document loaders, we can have a TextLoader, and from Langchain dot OLAMA, we can import OLAMA embeddings, and from Langchain text splitters, we can import recursive character text splitter. So the imports are ready. Now what we can do, we can load the few documents. So for that I can use the TextLoader, that is we have imported. We will have a list, and here we can have a TextLoader. I can have a two files are there. Okay, one is let me go to the samples. First one I can use this one. So let me copy the path, I can paste it here, and second one maybe I can use union, sample of union. So let me copy the path, paste it here. Okay, now we can have our docs. I can create a document alert here. Now we have the loaders here, so I can make it loaders. Okay, now we can doc.extend. I can extend here. This will be loader.load. I am loading the document. Okay, now we can create a child splitter. Okay, so this is the smaller one. Okay, what I can do, I can have a recursive character splitter. Here I can make a chunk size as 400, is equal to 400. Now I can have a vector store will be using Chroma vector store. Okay, so here I can give a collection name as full document. Okay, and here I can have a embedding function, can be OLAMA embedding. Here I can pass the model name as 53. Okay, so we have got a child splitter, that is a 400 character, then we have a vector store. Now we can have a in-memory store. Okay, now let's see. Now what we are going to do? Now we are going to create our parent retriever. Here I can have a retriever. I can use a parent retriever, parent document retriever. Here first I will mention a vector store. This will be our vector store. Okay, so this is the vector store, that is the Chroma vector store. That is, we are going to keep the child splitter. That is a small chunks that we are going to keep. Okay, and in the doc store, doc, in the doc store, what we are going to use, we are using the InMemoryStore. Okay, and here in the doc store, what we are going to save is we are going to save the parent document. Okay, then we will mention the child splitter will be the child splitter. Okay, so what is happening internally is, it will actually using the recursive child splitter to split the document within like 400 character, and it is actually keeping the parent document within the store or within the doc store. Currently we are using the in-memory store here. Okay, so whenever we use a invoke query, or whenever we use it with the LLM chat models, it will actually compare with the small document, so which will be very accurate and very fast. And but once the matches occurs, it will try to fetch the parent document, then it will return the parent document content, not the child document content, so that we will get the more accurate context. Okay, we'll see how this works. I can demonstrate that, but I am getting an error now. Parent document retriever, it says child splitter, something is wrong. Okay, it should be child splitter. Good. Now we can have a retriever.add document. I can add the docs here, and I am passing id as none. So we'll see, it's actually processing. Since I am using OLAMA embedding, it will not charge anything for me, and if you are using OpenAI embedding, you may get some charge. Okay, its execution is in progress. Now, meanwhile it's running. Why is it taking so much time? Okay, meanwhile it's running. We'll see what I can do. I can have a subdocs. Here I am going to run a vector store similarity search. I am going to ask for justice. Okay, so when we execute this vector store dot similarity search, okay, so since we are running within this vector store, this is a small chunk, right? So the size will be very less. Okay, should not be taking that much time. Okay, we'll see what I will do. I will post the video for now. Okay, so once this is done, we can start on this. I don't want to waste too much of time. Anyway, we'll see. I don't have any idea why this is taking so much of time. Okay, we'll see. Anyway, we'll wait and we'll get back. Okay, so this actually took 80 minutes. Okay, So maybe since this may be because I am using the Olama 5.3 in my local machine. Okay. So anyway, this is done. Now what we are going to do, we are going to just directly use the vector store. So vector store is the Chroma DB, and here we will be using the small, I mean recursive text splitter with 400 characters. So we'll see. So here what I have done, I just did a similarity search and executed this subdocs, and we'll see we'll see the length of, we'll see the what is there with the page content, the subdoc page content. Okay, so here we can see this is the 400 characters that we have got. Maybe I can check the length of this one. Length of this one, we'll see it's 272 characters are there. Okay, now what we are going to do, we are going to execute our retriever. So we'll see, I'm going to see that retrieval docs, I can say I can ask about retriever dot invoke. I can pass the same just in braille. Let me copy and paste it here. Okay, execution is done. Now let me print it, and here also we can use the page content. Sorry, this is not input schema, it should be invoke. Okay, should be invoke. Let me check it again. Okay, so this is the document, and we can have the page content. Let me check the length of the page content. Okay, see here the page content size is 75018. So what actually happened, so when we compare, when the parent document retriever compare with a query, it will internally compare with the vector store, which is the child splitter, which is actually using the child splitter with the 400 characters. And when the parent document retriever returns, it is actually returns the actual document, actual parent document, so which is saved in the doc store. Okay, so that is why we are getting the 7508 character length page dot content. Okay, so here we will have a question. Okay, we will have a question, if the parent document retriever returns this much big data, consider if my parent document is maybe 200 MB size. Okay, so how this will handle, or how this context can be handled by a LLM model. So for that there is another hack that is provided by the parent retriever or Langchain. So we can also create a chunks of parent document. Okay, we'll see that. Okay, here I can create a parent splitter, which will be a recursive splitter, similar to the child, but here the chunk size will be 4000 characters. Okay, now we have our child splitter. Child splitter will be the recursive, its size will be chunk size will be, I can make it 400. Here I can make it 2000, and this will be the 400. Now what we are going to do, we can similarly, in similar way we can go and repeat the same use case. Okay, so what we can do, I can create a Chroma vector store. I can create a Chroma vector store, and I can create a InMemoryStore. Now we can have a retriever. We can have a parent document retriever. Here what we are going to specify is that we can specify the vector store, and we can specify the doc store as store, and I can have a child splitter will be the child splitter, and one more thing that we will be mentioning is a parent splitter. Parent splitter will be the parent splitter. Just to make it little aligned. let me execute this. Something is missing. Let me check. Parent splitter. Okay, again the same mistake. Child splitter. Okay. Now we are actually specifying how the parent document is also splitted. So here we are specifying the 2000 as a chunk size, and the child splitter will be 400. So in this way, again, when this retriever is the parent document retriever invoke is called, it will first compare with the child splitter, which is 400 characters. Then this will be mapped with the parent. Internally, it will be mapped with the parent chunks. That is actually 2000 character size, and this will return the biggest or parent chunk size. I mean parent document, which is a size of 2000 chunk size. So even in this case also we are getting more accurate or more bigger context, which will help the LLM models to evaluate in a better way. Okay. Now what we can do, we can add the same thing. We can add to the document. This also may take 18 minutes. Let me see. So if it is taking too long, I will pause the video. Then okay, I think it's taking longer duration, so we'll pause the video, then we can come back after the execution. Now the retriever.add document is completed. This time it took only 4 minutes because we are actually saving only 4000 or 2000 characters from the parent splitter. Now we'll see, we can repeat we can repeat the same way that we have done earlier. First we can take a result from the Chroma DB, that is vector store dot similar search. I can search for maybe I can use the same thing, justice Breyer, and we have the result here. I can check the length dot result dot 0 dot page dot content. So we'll see the page content is 272, and I'm going to execute the same with the retriever, the parent document retriever. I can invoke result parent. I can invoke retriever dot invoke. I can pass the query. Execute this. Result parent. Dot 0 dot page content. We can check the length of it. First let's see the parent page content, and I can check the length of it. See, now we are actually getting a bigger context, that is 1278 context. So again, so when it is searched with the query, it will search internally with respect to the small context, and when it return the document, it is actually returning the parent document. It may be the entire document, or it may be a parent chunk with a higher chunk size. Here it is 2000. Okay, so that's about in this video. So if you have any questions, please put in the comment box. I will try to answer that, and I will be uploading this into my GitHub repository. You guys can download and try it. So please do like and subscribe. Have a nice day. Bye bye.